Hi there, folks. Today we're looking at solving radical equations. And we could probably figure this out without being taught any of this because we've already talked about this a little bit. So if you recall, when we started simplifying radicals that had exponents in them, we talked about the idea of the roots canceling with the exponents, okay? And it's that idea of exponents and roots being inverse operations. If I can go back to our good buddy Irmdas here, I think of order of operations as Irmdas, and I always write it this way for a couple reasons. One, it shows me that there's a tie between addition and subtraction. There's a tie between multiplication and division. There's a tie between exponents and roots. But also that those things are inverse operations. Like I undo addition with subtraction. I undo division with multiplication. I undo exponents with roots. I undo roots with exponents, okay? And that relationship of undoing exponents with roots we'll do later. Right now we're going to undo roots using exponents. And so it's that idea of a root and an exponent being inverse operations. In other words, they cancel each other out. And so when we look at that from a generic perspective here, it says, the nth root of a raised to the nth power just gives us a. Essentially, the nth root and the nth power cancel out, just like addition and subtraction cancel out, just like multiplication and division cancel out. All right, those things cancel out, and I'm left with the radicand. All right. For example, if I look at something like this guy, sorry, I was trying to erase those. There we go. If I look at something like this guy, this is a square root of x equals 5. And again, you have to remember that the square root has like a little 2 in here. All right. So to undo a square root, I need an exponent of 2. All right. If it's a root of 2, I need an exponent of 2 to cancel out. Roots and exponents cancel each other out. So what I'm going to do is I'm going to take this and I'm going to raise it to the second power. But just like any other equation that we've ever solved, whatever I do to one side of the equation, I am required to do to the other side of the equation. So over here, I'm going to raise this to the second power as well. And so what happens is the square root, the root, and the exponent cancel each other out, so I'm just left with x. Okay? They undo one another, all right? And it's that idea of working backwards sort of operations and undoing the operations as we go. Over here, it literally says 5 to the second power, which is 25. This is no different than solving any other equation that we've ever solved. We're just now starting to realize that exponents and roots are inverse operations, that they cancel each other out. And we've known for a long time that addition and subtraction cancel each other out. We've known for a long time that multiplication and division cancel each other out. But now we need to understand that exponents and roots cancel each other out. All right? And so if I look at this one, I have a cube root of 3. So a root that has a 3 can be undone by an exponent that has a 3. All right? Just like multiplying by 3, we undo by dividing by 3. All right? A root with a 3, I undo with an exponent of 3. Whatever I do to one side, I have to do to the other side. So over here, the cube root and the third power cancel each other out, so I'm left with the x. Over here, 2 to the third power, 2 times 2 times 2 is an 8. Well, that's it. If I look at the next one, the fourth root of x, to undo a fourth root, I need to use an exponent of, 4. If I had a 10th root, I'd use an exponent of 10. Okay, but it falls right in line with everything we've ever solved in the past, okay? We just now are understanding that roots and exponents cancel. So here the fourth root of 4 and the fourth power cancel each other out, so I'm just left with the x. Over here, 3 to the fourth power is an 81. And, use a calculator to help you out with that. There's nothing wrong with that. And then the last thing we should do, I didn't do it on any of these, but we should plug it back in and make sure it works, okay? Every once in a while, we will get extraneous solutions on these, which are solutions that basically we've done everything right, but the answer still doesn't work, okay? So make sure you plug it back in and check it. Each of these will work when you plug them back in, okay? We'll start plugging them in here with some of these more complicated examples, all right? And just a kind of a note before I reveal this, all right? So the directions here for the complicated examples are kind of making this a little bit more generic and a little bit more kind of from a memorization perspective. Keep in mind that you can still do the same thing that we've always done for solving equations. You work backwards through order of operations, all right? And you undo the operations as you go. If you understand that and you understand Irmdas order of operations, you already know how to solve each of these, all right? The trick is that there are invisible parentheses places, so we'll look at that in a moment, all right? from a kind of just remembering how to solve these for perspective, what we do is we isolate the radical. We get the radical by itself. And then we raise each side to the appropriate power. All right, we undo the radical. We undo the root using an exponent. And then we solve for what's left, okay? And see, the idea here is the reason we get the radical by itself is because anytime we have an operation that applies to multiple things, we have parentheses that are implied there. So if I have a root that has a bunch of stuff under it, that stuff is in parentheses. The reason we're isolating the radical is because it's in parentheses. We're undoing parentheses last, and we'll see that in a moment, okay? So again, we're just working backwards sort of operations, all right? We undo the operations as we go, and then part of doing that is undoing roots using exponents, all right? And then we keep solving. For example, if I look at something like this guy, again, if I were to think of it from the perspective of isolate the radical, I've got the square root of that x plus 1. The thing that's not part of the radical is the minus 4, so I have to get rid of that minus 4 first. But again, if you think about it just from the perspective of order of operations, that square root is happening to that entire x plus 1. There are invisible parentheses around this thing. And so if I was working backwards through order of operations, I undo addition and subtraction first. So I undo the subtraction by adding 4 to each side. And again, it's implied that there are parentheses around this. See, I can't undo what's in the parentheses yet. I have to undo the radical next. That's a square root, so I undo the square root by raising each side to the second power. See, it's a root with a 2, so I use an exponent of 2. The root and the exponent cancel out, so now I'm left with what was in the parentheses, the x plus 1. Now I can undo what was in the parentheses by subtracting the 1 from each side. So I get x equals a 48. And again, plug it back in, make sure it works. 48 plus 1 is a 49. The square root of 49 is a 7. Minus 4 is a 3. That one does work, so that's my answer. Okay? And notice, if, I kind of did it from the perspective of, hey, there's parentheses around that. Let's work backwards through order of operations, all right? That's the same thing you would get if you got the radical, the root by itself, then undid the root, and then went from there, okay? But understand that's why we're undoing the root before we undo anything that's underneath the root, okay? It's because there are parentheses that are implied, all right? Same thing with this one. We don't need the parentheses, but you could say there's parentheses around that. But work backwards sort of operations. I undo addition first, so I'm going to subtract 1 from each side. Now I undo multiplication by dividing. See, I'm working backwards through order of operations. Now I can undo the root by using an exponent. If it's a root of 3, I use an exponent of 3 to cancel it out. So here, the cube root and the exponent cancel out, so I'm left with x. Over here, 4 to the third power is a 64. And I'll plug it back in, make sure it works. The cube root of 64 is a 4, times 2 is an 8, plus 1 is a 9. And notice I'm just kind of plugging that back in my head real quick to make sure that the thing works. Okay? If I look at this guy, same kind of thing. There are parentheses that are implied right here. So I have to undo that x minus 5 last. I have to undo everything else before I get to that. So I undo addition and subtraction first. So I'm going to undo this addition by subtracting the 4 from each side. Now I undo multiplication and division. So I'm going to undo the multiplying by 3 by dividing each side by 3. And once again, the reason I undo the root before that minus 5 is the minus 5, the x minus 5 is technically in parentheses, okay? So I undo the root next. That's a root of 2, so I use an exponent of 2. To undo a square root, I square each side. The root, the square root, and the exponent cancel out, so I'm left with the x minus 5. And see, now I can undo what was in those parentheses. I'm going to add that 5 to each side. So I end up with x equals 6. But now plug it back in, make sure it works. So if I plug the 6 back in, 6 minus 5 is a 1. The square root of 1 is a 1. Times 3 is a 3. Plus 4 is a 7. But this is supposed to equal 1. Maybe I plugged it in wrong. All right, let's try again. Let's make sure. So I'm going to plug the 6 in here. Ready? 6 minus 5 is a 1. So I have 3 square root of 1 plus 4. And again, I just want to make you aware of this. That's 3 times 1 because the square root of 1 is a 1. So that's 3 plus 4 is a 7. And so the question becomes, obviously that doesn't work, is this an extraneous solution or did I mess something up as I was solving? All right? And the answer here is that it's an extraneous solution. I did everything right. I solved this correctly. But the situation is impossible. All right? So this answer doesn't work. And that was the only answer I had. So the final here is going to be no solution. Okay? And that'll happen. All right? And you might be able to notice the moment where you could have identified it in this one. All right? You won't always be able to identify it early, but it's right here. Right here in this step, I had the square root of x minus 5 equals a negative 1. And there is nothing I could take the square root of that would give me a negative value. The only way a square root is negative is if I already had a negative on the outside here. And right at that moment, I could probably tell that this one is no solution. All right? But again, be aware of that. Understand that with things like square roots, because there are domain restrictions involved, that you can get extraneous solutions. So make sure you check your answers and plug them back in. Okay? If I look at the next one, this one is pretty tough. All right? Because as I look at this thing, I want to get the variables together, but you see that I can't. All right? If I were to try to add that square root of x over to the other side, I can't combine it with the other x. And that's an issue. All right? The variables can't be put together. And so what I do here is I kind of go with that route of let's get rid of one of those square roots. The thing that's keeping these variables apart is that they're both trapped in square roots. All right? If I could get them out of the square roots, I could combine those in some way, and then I could continue to solve. So the first thing I want to do is I want to undo this square root. So right here, I'm going to undo this square root by squaring it. And whatever I do to one side, I have to do to the other side. Notice I have to do that to that entire side. And so over here, the square root and the exponent cancel each other out. So that's an x minus 15. Over here, I have that whole thing squared, and keep in mind, this is what that means. It means this guy times itself. That's what squaring something really means. All right, is multiplying by itself. Well, this is that situation that we looked at when we were multiplying radical expressions, where I have to distribute, okay? So here I have to distribute this 3 to each of these, which gives me a 9 minus 3 root x. Then I have to distribute the negative root x to each of these. Again, it's just outside times outside, inside times inside, which is going to be a minus 3 root x, and then a plus square root of x squared. Okay? Over here, it's an x minus 15 still. And now I just simplify. Let's simplify that square root a little bit. Here I have some like terms. That's a negative 6 root x. See, we're using those ideas of simplifying radicals. And then right here, the square root of x squared is just x. Okay? Remember, the root and the exponent cancel each other out. We've just been talking about that. Okay? Those cancel, so I'm just left with the x. See, now the x's are free to get together. See, I can take this and say, hey, I want to get rid of one of these x's. So maybe I want to get rid of the x that's over here. So I'm going to subtract x from each side. See, as soon as I took that square root, I'm freeing some of those variables from the square root so that I can get them together. Well, they end up canceling, which is okay. So now negative 15 equals 9 minus 6 root x. And now from here, well, this is kind of a simpler type of these problems. If I were to just ignore everything that I've done so far and hit the reset button, and I ask you, how do I solve this? Well, I've got a 9 and a negative 6. I just start solving. I undo the addition first, so I'm going to subtract 9 from each side. So that gives me a negative 24. And now I say, oh, well, how do I undo multiplying by a negative 6? I divide by a negative 6. See, I'm back to doing one of these simpler types of examples. So that gives me a 4 equals the square root of x. And now how do I undo the square root? It's a root of 2, so I undo that by squaring each side. Okay? And so what I end up with here is x equals a 16. But go back, plug it back in. Let's see. Ready? 16 minus 15 is a 1. The square root of 1 is a 1, so on the first side I get a 1. The second side, the square root of 16 is a 4. 3 minus 4 is a negative 1. Well, that's not quite true. So I did all that work, and turns out that's an extraneous solution. So it's no solution for this one. Okay? And keep in mind, it won't always be no solution when I have this situation. I could easily have changed this one. If I had the square root of x minus 3 instead, well, then this solution would work. Okay? And so keep that in mind. It's a very subtle difference between something that's extraneous and something that works. Make sure you plug it back in and check it. So here, just doing a couple more of these examples. Again, keep in mind that it's implied that there's parentheses here. That square root applies to that whole thing. So now work backwards through order of operations. I undo addition by subtracting. Let's give us some practice here. Now I undo multiplication with division. Now I undo roots by using exponents. And now I undo what was in the parentheses, which happens to be subtraction this time, by adding. Okay, plug it back in, make sure it works. This one does. Okay. If I look at the next one, once again, I undo, there's parentheses that are implied here. Let's start with that. Okay, that whole thing. I undo subtraction by adding. Now I undo roots by using exponents. So I use an exponent of 4. Now I undo what was in the parentheses, which happens to be multiplication this time, by dividing. So again, I'm just working backwards through order of operations and undoing the operations as I go. That one works when you plug it back in. All right, it's the same thing that we've been doing, but now we've added roots and exponents canceling each other out to the mix. All right, we still work backwards through order of operations. We still undo operations as we go. All right. This one, I undo subtraction by adding. And once again, there's parentheses that are implied here. Now I undo the root using exponents. And see, now I'm free to undo what was in the parentheses. In the parentheses, I had a minus 3 and a times 4. I undo the minus 3 by adding 3. I undo the times 4 by dividing by 4. So again, just working backwards through order of operations. Plug it back in, make sure it works. This one does. Okay? If I look at the next one, once again, there are parentheses that are implied here. So I undo the times 1/2 that's on the outside. I undo times 1/2 by multiplying by 2. Remember, a times 1/2 is the same as a divided by 2. I undo divided by 2 by multiplying by 2. And now I undo the root using an exponent. So it's a root of 2, a square root. So I undo it by raising it to the second power. Now I undo what was in the parentheses, which happens to be a plus 4, so I subtract 4. Plug it back in, make sure that it works. This one does. Okay? How about this guy? When I look at something like this, students get really thrown off when they see examples like this. But this is a more literal example of how that thing is in parentheses, okay? And really, this is the same as the examples we've been doing. Remember, the 1/2 power is the same as the square root. And if it makes you feel more comfortable to rewrite this one as the square root of 3x minus 1 plus 2 equals 5, then rewrite it that way. Subtract the 2, undo the square root, then undo what's in the parentheses. You don't have to rewrite it like that as long as you understand they're the same thing. Here, subtract the 2 from each side. And if I understand that this thing right here, the 1/2 power, is the same as the square root, well, I undo the square root by squaring each side. I undo the radical, I undo the root by using an exponent. And so what happens is these actually cancel. And again, think back to rules of exponents. You actually multiply the exponents. 1/2 times 2 is a 1. So you're just left with the 3x minus 1. Now I can undo what was in those parentheses. I have subtraction and multiplication. I undo the subtraction with addition. And now I undo that multiplication with division. And I can leave it as a 10/3, or you could write it as a mixed number. That would be okay. All right. Plug it back in, make sure it works. This one does. All right. And then the last one here, again, if you need to rewrite it as a radical, that's fine. Take it off to the side here and say, you know what? That's the same thing as the cube root of 4x equals 2. So now you undo the cube root by raising each side to the third power. You don't have to rewrite it like that. It'll undo the same way. Raise each side to the third power. And once again, these guys are going to cancel. So you're left with the 4x. Over here, 2 to the third power is an 8. Now undo what was in the parentheses, divide each side by the 4. All right? So again, we are doing the same thing that we've been doing solving equations since the beginning of time. We work backwards through order of operations. We undo the operations as we go. But now the only difference is we're throwing radicals into the mix. Now we understand that roots are undone by exponents, okay? And understand those invisible parentheses makes it really easy to determine, all right, what do I have to undo next, okay? And this one does work if you plug it back in.